here's something I've been working on also. My floodlight towers on the layout are all hooked on the same circuit. I think there's 4 of the 16 light floodlight towers and 1 of the 8 lights, and 1, 2, 3, 4, 5, about 6 of the 2 lights, and 1 or 2 of the little singles. Anyway, when I added them all up, I think it was coming close to 5 amps or something. So I was running them right now off of the MTH accessory port for the 14 volt, and the max for that is supposed to be 3 amps, and I'm running like almost 5 amps out of there, so I don't know what the story is with that. So anyway, I was hoping I could find something that would be about 16 volts instead of 14 volts, so they'd be a little brighter. I don't really want to run them at 18, but I needed a lot of amperage. And I found this. It's an old computer power supply, an IBM. It's 16 volt DC output, 7.5 amps. So this would be perfect. I got it for $9 off of eBay. The guy sent me the wrong power cord. You know, it's, see if I can show you. It's got the 3 position. He sent me a 2 position, but I had one. It's like a laptop adapter. So I think what I'm going to do, I saw a diagram somewhere. It wasn't on here. Yeah, it was on here, where they showed positive was, looks like positive is the 2 over here, and negative is the 2 over here. And the only reason I figure they tie all them together is either for redundancy in case it breaks, or probably for the amperage. If you tie them together, you can get the higher amperage. So I'm going to try to dissect this thing and pull the wires out and see if I can measure on my meter the 16 volts at 7.5 amps. Okay, so I cut the plug off, and then I realized I could also cut off this, it's for interference. I forget what they call them. It's a block for interference when you're going up to a computer. I don't care about that at this point. So let me see if I can dig into here and see if I can find anything useful. Try not to cut too deep. Okay, this is probably all shielding. Let's look inside here. Wow. Looks like all that's in here is 2 really fairly heavy gauge wires. Let me just see. Voltage DC. $16 volts. Huh. This isn't going to be too difficult after all. So I just need to figure out a way to tie something onto these so that they can be hooked up as a supply for power to my lights. So let me think about that for a second and I'll come back. Okay, I looked under the layout, and where I need to hook this up is a terminal block, and it would work really well with these spade connectors. So I picked the bigger ones, the blue ones, instead of the red ones because these wires are pretty big. I think the plan's going to be shrink tube this one to protect it, and then shrink tube the whole thing when I'm done, and hope that I can get that over top of that joint. Maybe. So I don't really need a piece that big, do I? I like to put my connectors in first. That way, as soon as I get it to the depth that I want, I can cinch it down. That is, if I can get it in here. When it's stranded like that, sometimes you gotta really work at it, get it in there. Ah. There we go, just till it sticks out the top a little bit. All right, force of the two hands. Yeah, it's going nowhere. Let's try another one. There we go. Now, I realize that it's tight, but I'm going to two terminals that are right beside each other, or maybe one apart. So I wanted this. This is like a custom fit. You could have left more on there. Let's see if we didn't do any harm. Here, whoops, here, and here. 16 volts. Excellent. Okay, I think I'll look at mounting this under the layout. Okay guys, so we've taken a field trip underneath the layout table. Here's where I ended up mounting the adapter. There's 1,000 ways to mount it. In the end, I always find tie wraps work about the best. Power it from that power strip right there. Comes out. The wire comes over here. Over to here. Up through. And to right here. If you'll notice the two blue ones, that's where our power is, which distributes out through that terminal strip to all the red ones. And shut up. Don't make fun of my wiring. My wiring works. Years of practice. All right, let's go up and try it out. All right, let's give it a shot. Oh yeah. Yeah. Look at that. Look at that one over there. Yeah, that's going to work pretty well. Before it was 14 volts. It was going through the accessory of the MTH Z4000, 3 amps maximum. Now, yeah, now they're 16 volts. Look, they're brighter. You see three of them there. You got here, this one over here, and over here, and that one. Yeah, that's going to be nice. 7.5 amps I can run there, and I'm probably drawing about 4.75. I'm under 5, so I still have room to grow if I really have to. All right, cool project. One quick thing I failed to mention is when I power on my layout with this switch over here, that powers everything here. So I can turn on the Z4000, powers my Lionel bricks, which are mounted back here, my Tortoise switch machines with go through my control panel. And I can hit this button here, which turns on all of my accessories up on the layout. The houses, the lighting in the houses. See, they're not on right now. So what I'll probably do eventually is I'll just go get a switch, a toggle switch, and I'll put one here, and that'll allow me to toggle the yard lights on and off from that adapter that I just installed. It'll be real simple to cut that switch in line. That way they won't be on all the time. I'll just get a 10 amp toggle. It works great, so I'll keep an eye on it. And if you want to do something like that, you know, look for one of those power adapters online. It was an old IBM laptop power adapter, 16 volt, 7.5 amp. It was real easy to cut the wire off and do what I wanted to do to it. Now it's DC, so you're not going to be running accessories off of it most likely, but I know I was doing bulbs and I figured I'd probably like to run my bulbs off DC instead anyway. Great. Thanks for watching, guys.